Thank you, Tabi. Welcome everybody to our webinar about the intersections between climate change and biodiversity. To start us off, I would like to call on our colleague Des Naidu to do a bit of an introduction, and then we'll kick off with the presentations.
Hello, everyone, and thank you very much, Chair. And it's great to see this many people who are already online. That's excellent. I want to offer a few words of introduction, really. I mean, you will know from the agenda that we have some of the best experts in this domain that are going to talk to us about the topic, and in particular, the stories, the models that we are using to help us to think through where we need to go and to organize for the decisions to become accessible and practical for most people. And this is really excellent. So a few words around the context in which we're operating. I mean, the first thing that I think we're alive to in 2024 is a potential mega policy shift in the world. And not individually, but in many places, but simultaneously. So we are in that year of 49 national elections in the world, and that's quite massive. And some of the shifts will be potentially in a dangerous direction. I mean, many folk have been talking about the possibilities with November and the US election and around what that may mean for the US's own positioning around climate change matters and the prioritization of climate change and potentially in a negative direction. And we just today learned that Mexico has a new president, its first female president, Claudia Sheinbaum. And I think it might make you a little bit happy to know that she's in fact a climate scientist. And I say is because I don't think you ever stop being a climate scientist. But this toing and froing around this in the world is going to be a major phenomenon in this year and a place to watch fairly carefully at national level and also at supranational level. I mean, the continent of Africa has been quite expressive around the issues of climate change and in particular the issues of climate risk. And the AU Peace and Security Council has met under the banner of the Climate Development Security Nexus twice already, to offer its pronouncements on where it needs to go. And you can be very happy that you're part of a continent that is the first in the world that has adopted a risk assessment around climate security. And that report was launched at COP28 in Dubai. But there are many shifts in other directions and many platforms that are going to organize to use those shifts to move, hopefully, global policy in this matter. And one of the important stops along the way is going to be the G20 this year. And the G20 under the presidency of Brazil is very keen to put climate right at the top of the agenda, if you like, as a bridge to both South Africa's own presidency of G20 next year, as well as Brazil's hosting of COP30 next year. And they want to do it in the Amazon. So let me just talk through a few notes around this and how this relates to the topic that we're engaging today. Now, the issue around climate being a principal risk to the global economy is something that has been expressed repeatedly throughout the year, starting all the way back in January this year with the World Economic Forum and the publication of the Global Risk Report, which they do every January. And it's quite explicit that both in the near term and even more explicitly in the 10-year term, that climate change dominates the agenda. In fact, in the 10-year term, the top 5 risks to the global economy as it is projected from the survey now will be associated with climate change. And the multiple facets of that climate risk is something that we have grown accustomed to. We talk a lot about the extreme weather, and the extreme weather is seriously extreme and very frequent and absolutely pervasive and highly intense. And we're experiencing a major event that has some link to climate change almost every month now in this part of the world, South Africa and the surroundings. And the severity of this is extreme. I mean, we were having floods in Kenya, and it's just passed, and we're recovering that into that. And now we have the same thing in Nelson Mandela Bay, and we have drought conditions to the extent where Zimbabwe has declared a national food crisis. And Zambia has declared a state of emergency. So the extreme weather phenomenon is a very real phenomenon. But in addition to that, the stealth impact, if you like, of global warming and changing precipitation patterns are having very significant impacts on livelihoods. And one of the direct results of that is the issue of climate migration. And you know that South Africa's own election has had a fair amount to say in the run-up to the election on issues of migration and migrants. And this is a phenomenon that's only going to increase in our part of the world. And this is backed up by various global reports. The most authoritative perhaps is the Groundswell report from the World Bank. And then the bit that we don't talk about enough, I think, is the whole issue about violent extremism and conflict. And one that is climate change related, but in a different way right now is in Cabo Delgado. And Cabo Delgado has become a major hotspot in advance of the Mozambican elections. And we have an unprecedented situation of a current president and a potential future president both pronouncing on this issue simultaneously. But fortunately, both in the same direction. And then South Africa has been seized with the discussion around what the implications are and the risks associated with the transition and how to make a just transition genuinely just, and the issues of jobs and livelihoods, the future of the mining towns and the power towns in Mpumalanga, and in fact, beyond Mpumalanga, are very much in all of that mix. And then some of the new issues that are coming out in the global discussion, and this is certainly finding a space of engagement in various of the major economic and political fora that have been gathering around the world with great earnest, is the issue of climate finance, but also the issue of climate change on the financial and economic health of various countries in the world, and the impact on debt in particular. And many pronouncements have been made on the debt issue. In fact, Africa is now pronouncing itself on a new nexus, the nexus of climate investment and security associated with not getting those two in the right kind of condition, as one of the major issues going forward. And the need for an accelerated reform of the global financial architecture is a part of that package. Then the other thing that's coming through very strongly, the issue around the trade instruments associated with low carbon economies. And one of the things that's become really imperative is the issue of the criticality of timetables and access to very scarce resources associated with a low carbon economy. So all of these are some old factors, some new factors, but all of which are organizing themselves into new narratives around how we engage the issue of climate change, and will become very germane to both the short-term as well as the long-term decisions we need to make as a country in order to find ourselves in the right sweet spot of the right momentum towards decarbonization and creating a more resilient South African society, while minimizing the losses that inevitably have to come out with loss and damage associated with our inability to adapt quickly enough, the right kinds of investments in that adaptation, and ability to keep our economy on an upward growth path while going through all of that. Now, that sounds like an almost impossible formula, but this is precisely what we need to engage the issues of the modeling and the narratives that go along with that modeling in order for us to find those sweet spots and organize for the right roadmaps of decision-making to get us to those sweet spots. Now, what's particularly important about the engagement that we're having today is that issues of ecosystems and biodiversity, which were the predominant conversations associated with climate change from very early on in the UNFCCC, have for the last little while, for the last decade or so, lost their primacy in those discussions as the energy transition discussions became paramount. The energy transition discussions and the climate finance discussions. and to some extent, some of the issues around loss and damage and adaptation. But a re-recognition of the biodiversity asset, both locally, like South Africa had with both its economic strategy for biodiversity as well as the biodiversity Indaba, but also internationally with the CBD in particular, but also the CCD. There's a desertification convention paid a fair amount of attention to the biodiversity issue. But the CBD, the Convention on Biological Diversity, which South Africa signed onto, and its slogan 3030 is something that we have to put strong actions towards. So the whole issue around organizing for this nexus of firstly maintaining the biodiversity and even growing the biodiversity asset that we have through multiple mechanisms, including recognition of the asset, and then the whole notion of biodiversity stewardship is absolutely critical. Its link to the economy and to climate in that nexus is something that's becoming more and more important. Firstly, the biodiversity as an asset in its own right, but also biodiversity as an essential part of the ecosystem that will eventually guarantee the climate resilience that we want to see inside South Africa and in the region, in the continent, and in the world. Now, all of these things seem to require a very strong and very large upfront investment. But the dividend trail behind that can be quite interesting. I mean, for example, one of the experiments that South Africa has led the world in is the concept of the working for projects, the first being working for water. And then subsequently, we had working for fire and working for wetlands. And unfortunately, the funding streams associated with that have dried up in the most difficult way. In fact, the only fully funded program currently is, in fact, working for fire. And there's almost a phase out of the other two. But a new discussion is starting to happen around this. And if you like, the domain now is talking about working for climate, around having these public work type programs, preserving the climate resilience capacity of the natural ecosystems and maintaining that in the right kind of way. And some of the projections already made is that this could employ in and about 172,000 people a year in this enterprise. So while we're engaging the issues around the potential job losses associated with the energy transition, we're looking at the possibility of an absorption factor in this broader economic diversification naturally, but there's one subset associated directly with biodiversity that could put us on a very, very firm footing. So colleagues, this is a really exciting sphere to engage. And we have some really top-notch experts that will walk us through the stories that are being created and the science that backs up those stories, all of which is going to help us to get into a much better space around understanding the problematique a lot better, but also in a way that's pointing more directly to both the solutions and the short-term and long-term decisions that we need to make. So Chair, with those few words of introduction, I hand back to you. Thank you very much.
Thank you so much, Deza, and thank you for that context, which places the speakers in a comfortable position to further extend on those points. So thank you to the speakers for your participation. We are looking forward to your presentations. And as you know, you've each been allocated 20 minutes to present, and we will then explore more during the question and answer phase. And to the audience attendees, thank you so much for coming. We have a great number. So please feel free to put in questions in the chat, add to the discussion points, and we'll have a good time. So Professor Engelbach is from the WITS Global Change Institute, and his topic will be projections of South Africa's climate change futures and tipping points. He will then be followed by two speakers, Mr. Aaron Hartwig and Mr. Stein van Hummelen from Cambridge Economics. Econometrics, and they'll be discussing the impact of trade and climate damage on South Africa's economic strategy. And then last but not least, we have Dr. Anthony Godden and Mr. Paul Haji Lazaro from the French Development Bank. And they'll be talking to us about the socio-economic and spatially explicit assessment of nature-related risks and looking at South Africa as the case study. So without further ado, Professor Engelberg, can you please tell us more?
Thank you so much, Jay. Yes, let me start by sharing my screen here. Thank you so much, Jay. Thank you, Des, again for this introduction. And yeah, I feel very privileged today to give to this large audience an overview of the latest climate change science we have available for our Southern African region. I'll also talk about something that we refer to nowadays as climate change tipping points. I'll try to explain what these are and what they may mean for our region. I think it's always good to start talking about what's happening right now before we talk about the future. And just for all of us in South Africa currently affected by the cold and the rainy weather, there you can see what remains of the cut-off low, the broad rainfall across much of the southern parts of the country in the last couple of days. More than 250 millimeters of rain has been recorded at some weather stations in the Quebec region. So an example of an extreme weather event that Jessica has just referred to. And first prediction of today is that this is going to be a cold week. You can see there to the west, there's another system approaching. So there's more rain coming late deep into the week all over again as another cold front is going to move across the country. This one will bring less rain, however, than what was caused by this cut-off low. But that's a big part of climate change, of course, is to also think about how systematic global warming is going to change the weather systems that influence us here in Southern Africa. And will we indeed see more of these extreme events in the form of droughts and floods as the world continues to warm? I'd like to share some sobering news for those who are not familiar with this. We are now living in the dawn of the era of 1.5 degrees Celsius of global warming. So the first 12-month period that has exceeded the threshold was February 2023 to January 2024. May 2023 to April 2024 was the warmest 12 months ever recorded by humans, 1.61 degrees Celsius, above the pre-industrial average temperature of the planet. So indeed, we are now living in the days of global warming. We are probably already living in the first decade for which the average temperature will be, for a decadal average, warmer, 1.5 degrees Celsius higher than the pre-industrial average. So I'm afraid that the chance that we did have still maybe 5 years ago to avoid this threshold from being reached has come and gone. And it's now going to be about trying to prevent global warming from reaching the 2 degrees Celsius threshold. But we will now have to live in a more dangerous world, a world that is warmed by 1.5 degrees Celsius. And as we'll see today, that means, for a start, more extreme weather events occurring in most parts of the world. And there are also some risks that exist now in terms of irreversible sea level rise. Just another reflection on what's happening right now. We've just lived through an extraordinary dry January to March season across much of Southern Africa, especially over our neighboring countries to the north. So the top left graph there shows the rainfall deficit from October last year until May this year. And you can see that the rainfall anomalies have been negative as much as 300 millimeters below normal was the rainfall in parts of northern Botswana, southern Zambia, and over much larger parts of southern Africa. The dry conditions also extended, of course, into the maize-producing regions of South Africa in the Northwest Province and in the Free State. So Malawi, Zambia, and Zimbabwe have all declared states of disaster. And I've just returned from a 2-week travel period visiting these countries. And several of the colleagues tell me that they regarded the drought as historical in terms of these negative rainfall anomalies. Was it caused by climate change? Or was it just a consequence of the natural El Nino, La Nina cycle that bring drought and flooding to our region? I'll also talk about this today. Of course, this past season was El Nino season. El Ninos are typically dry in Southern Africa. And we've also experienced, in fact, the 4th strongest El Nino on record this past summer. And just before I talk climate change, just a last bit of information on what's happening right now. This is good news. The El Nino is dying. It's weakening. This is a prediction of the state of the Central Eastern Pacific Ocean moving into the next few months. And those blue bars replacing the red bars mean that increasingly we are now going into a state of likely La Nina state when the Pacific Ocean becomes cool. This will hopefully slow down the current spell of rapid warming of the planet a bit. And for us, this likely means widespread and good summer rains this upcoming summer, if this prediction will indeed hold true and the La Nina will indeed fall. So what about climate change? Let me give some of the basics very briefly, and then I'll show projections of climate change for our region. On this left-hand side graph, we are looking at the carbon dioxide emissions into the atmosphere from the year 2015 onwards. And what you can see is back in 2015, we've been at about 40 gigatons of carbon dioxide being emitted into the atmosphere every year. That has now increased since, of course. And as we meet today, it's all about the decisions we are still going to make. We still need to make as the nations of the world and the countries of the world. We can follow those red lines into the future, which are futures where we remain strongly reliant on coal and oil deep into this century to fuel the world economy. And the dark blue line and the light blue line, that's the opposite type of future, where we decide to aggressively implement the Paris Agreement on climate change. And as per the light blue line, we achieve carbon neutrality more or less in the middle of the century. Now, these decisions will really determine the level of global warming and our climate change futures, also here in Southern Africa. So you can see those dark red lines. If we look at this projection of the level of global warming into the future, take us to 3 to 5 degrees Celsius of global warming at the end of the century. And I'll demonstrate to you soon that that will mean devastating impacts in Southern Africa, also in terms of impacts on biodiversity. If we can achieve those light or dark blue lines, we still have an excellent chance of restricting global warming below 2 degrees Celsius. But back in 2021, the IPCC, Intergovernmental Panel on Climate Change, made the assessment that it is more likely than not that we can no longer avoid the 1.5 degrees Celsius level of global warming. We just left the mitigation process for too late in the day. 3 years later, and the level has been exceeded for the first time. And there's no realistic way to think that we can now phase out coal and oil so quickly that we stand a chance of still staying below the 1.5 degrees Celsius level. I think we now have to increasingly prepare for impacts of 1.5 degrees Celsius of global warming. We are seeing the first years happening now at that level, but there's still an excellent chance of restricting global warming below 2 degrees Celsius. Colleagues, a few years ago, I was talking as an IPCC author about the top left map as something of the future. Now it is with us. The 1.5 degree level of global warming has just been reached for the first time. Not yet on the average, just a single year. But that is how we expect temperature patterns to look like globally, across different regions of the world, for a global warming level of 1.5 degrees Celsius. This is the world we are living in right now. And I'll just be very brief and say, have a look at Botswana. Botswana is the place in the southern hemisphere that is warming the fastest. And it has everything to do with the regional climate system here in Southern Africa. So we should take note of the fact that here in Southern Africa, our interior region temperatures are warming faster than the global rate of warming. So that's an important fact to take note of. Now, as we will move to a 2-degree world, top right, if we don't mitigate climate change, that world waits for us in the 2040s. You can see that Southern Africa will keep on warming at a relatively high rate. And so will be the case under 3 and 4 degrees Celsius of global warming that you can see there in the middle slide. So in the central interior regions of Southern Africa today, the warming that has been recorded on the average over the last 100 years is already 3 degrees Celsius. So over that central part of Botswana into southern Zambia, we are in fact warming at more than twice the global rate of warming. So that's an important aspect to take note of our own climate system. Now, at the same time, our region is projected to become generally drier. So if you look at these rainfall maps into the future, the 1.5 degree world top left is emerging right now. The majority of climate models are projecting that our largest Southern African region will become drier. That's the most likely future. And that drying will intensify as the level of global warming intensifies. It is for this reason that the IPCC declared Southern Africa as a climate change hotspot in 2018. And the reason was that when a warm and dry region such as ours become even warmer and drier, then there are limited options for adaptation. So I'll now just briefly share some regional projections. I have to go fast, unfortunately, for our region. And this is work that we are doing through a big project funded by Germany and the Southern African Climate Services Center in Windhoek, through which we generate these detailed projections of climate change for Southern Africa. And we've over the last year or so been working with colleagues in National Treasury, Stellenbosch University, and several other international partners towards also investigating what these changes may mean for our South African economy. But in a nutshell, and I'll be brief, if we look at these more detailed projections of climate change in our region, top left shows the last 20 years average temperature climate, and the other 3 graphs are projected changes from a best case scenario to worst case scenario. We can see that in terms of temperature futures, all climate models agree that our region will continue to warm rapidly relative to the global rate of warming. If we look at rainfall futures, those top right and the bottom maps, most climate models project that our region will become generally drier. But there's a minority of credible climate models that are projecting rainfall increases over our eastern escarpment region, including the Megadam region. So over that part of South Africa, there is uncertainty in terms of our rainfall future. But let me point out the majority of models are pointing towards a drier future. And over regions such as Botswana, there's no uncertainty. It's a drier future that awaits. In terms of heat wave days, drastic increases. This is a major risk for our biodiversity, our agriculture, our people living in informal housing. All climate models agree that in the next 20 years, we will see heat waves of an unprecedented amplitude in Southern Africa. There's no uncertainty about it. High fire danger, of course, in a world that becomes so much warmer and likely drier, we should expect increased meteorological fire danger. And as long as there's an El Nino, La Nina wet dry cycle, we should expect that there will be from time to time enough vegetation to burn. Fire is becoming an increasing risk for us. We've seen this also at the end of October last year with the fires in the Free State and how our farmers responded to that, calling for a state of disaster. Soil moisture. In this warmer world, soil moisture will be decreasing. There's no uncertainty across climate models because the higher temperatures result in more evaporation and evapotranspiration from soils, from vegetation, from the big dams. But in terms of agriculture, this, if you think about this result, it effectively means that we are likely heading towards shorter growing seasons in Southern Africa for our crops because of reduced moisture availability. Although most climate models are in agreement that our region will become likely drier, at the same time, most climate models are saying extreme rainfall events will be increasing over eastern South Africa at least, in the majority of models. So that's interesting. It's not only the rainfall totals that are changing, but also the nature of the rainfall in eastern South Africa, heading towards more extreme events. If we zoom into places such as Theewaterskloof catchment and we look at annual rainfall anomalies on the x-axis and temperature anomalies on the y-axis, we can see how Theewaterskloof catchment is projected to change from today's world in the blue and purple dots with natural variability, some dry and some wet years, towards a future world in the middle of the century and the end of the century, the orange and red dots that are drier. There's a clear regime shift in the climate happening in the winter rainfall region. What will this drier Western Cape mean for biodiversity? All that richness of species have evolved in winters that are cool and warm. Now those winters are becoming drier and much warmer. There's a bigger risk for fire in the fynbos. So future climate change in Southern Africa, I'll just say in a nutshell, it's a region that is likely to become drier. There's uncertainty over the Eastern Escarpment about that drying signal. At the same time, the region is projected to become drastically warmer, and the El Nino La Nina cycle will persist. So against that background, I want to conclude by saying a few words about tipping points. Now for today, I'll just define a tipping point as an unprecedented climate change event, climate change induced event, that becomes possible because of a changing climate system. So the climate regime shifts, and now unprecedented events that we've never seen in the historical past become possible. Now in 2022, the Hawaii State Emergency Department said the risk of humans losing their lives in Hawaii from wildfires is low. But in August last year, more than 100 people died in fires in Hawaii. It's a clear example, an unprecedented event. In this case, there's evidence that it was fueled by climate change. But the point that I want to make today is that the event was also unexpected. And that's why it was so dangerous. Last year, 1 month later, September last year, 11,000 people died in one day in Libya, in the city of Derna, the biggest flood in living memory. A climate change fueled weather system caused 400 millimeters of rain to fall in one day in a region where the average September rainfall is 4 millimeters. The dams couldn't take it, they broke. We all know, of course, there's lots of intense politics and governance issues in Libya, but it's still climate change that caused that brought this event. Unexpected, unprecedented disaster. In our own region, almost done, Chair, tropical cyclone Idai, more than 1,500 people lost their lives, March 2019. This was the first tropical cyclone in the historical record that caused more than 1,000 people to lose their lives in Africa. But just 4 years later, it happened again. Last year, February and March, tropical cyclone Freddy, it also killed about 1,500 people. So there's evidence that the tropical cyclones are becoming unprecedented in the amount of rainfall they cause and the intensity in our part of the ocean. And that's the last point I will make. It is critical that we think about what the unprecedented risks are, things we've never seen before, because if they're unexpected, they are disasters. I think we must think about the possibility of a drought of magnitude never seen before, so strong that our reliable integrated valve system that has never let us down will not be able to supply Gauteng with water. So the Gauteng Day Zero drought, I think that is our biggest single economic risk. If we look at the recent IPCC reports, they project the likely collapse of the maize crop and the cattle industry under 3 degrees Celsius of global warming. But that's just looking at the biophysical impacts of heat stress. If we take into account socio-economics of farming, that risk of collapse is probably awaiting us earlier in the future. From a biodiversity perspective, colleagues, I've just spoken so much to our experts our colleagues in Botswana and Namibia. They are so concerned about wildlife increasingly being fenced in with a dependency on groundwater and boreholes. In a warmer world where you have droughts lasting 4 to 6 years, there will be no forage. There's a risk of major die-offs of wildlife in these fenced-in regions centered in Botswana. It's a major tipping point risk. Heat waves impacting on our communities, all our people living in informal housing, extremely vulnerable, literally lives at risk if you don't have easy access to cool water and you live in informal housing when the heat wave strikes. The climate models are clear. The heat waves of the next 20 years will be unprecedented in Southern Africa. Finally, in the warmer Mozambique channel, can an intense tropical cyclone such as these ones that have hit Beira and Blantyre, can they go further south to Maputo or even Richards Bay? It's another tipping point risk. This is my last slide. Nowadays, when I give a talk, I always try to say something positive at the end, because there are two things. There are two things that are important. We can completely avoid many of these tipping point events ever from being reached, right? Because with strong climate change mitigation, we can still keep global warming to below 2 degrees Celsius. So there's still hope for climate change mitigation to be successful in that respect. Although we must also accept the 1.5 degree level can no longer be avoided. And then finally, our climate science, and in countries like South Africa, where we have events like this and the government that listens to climate science, there's still hope that we can prepare. So we have the science in place. We have government departments in place and the Presidential Commission that really want to prepare for climate change. So at least in the case of our country, if we do the hard work and we do the science and we talk between science and governance, we can prepare and we can make sure that unprecedented events at least are not unexpected. And with that, Jay, I hand back to you.
Sure. Thank you, Prof. Engelbert. I know I'm not the only one in the room who felt chills and is feeling quite sober at the realities of the fact that living at 1.5 degrees Celsius pre-industrial levels has consequences. It has consequences on people, and that means, of course, that it will have consequences on the national economy and public resources. And I think it's fitting then that we have the next speakers, Mr. Hartwig and Mr. Humelen, to tell us, what does this all mean for South Africa's economic strategy going forward? What challenges can we anticipate, and are there any opportunities? Please take it away.
Thank you very much. Let me share the screen and we can already start. Wonderful. So, first of all, very happy to be here, and we have just heard an excellent presentation about what potential climate damages can be out there and how the climate change can harm the South African economy. And in the followings, I would like to emphasize that it's not only dangerous what can the climate change cause in South Africa, but actually it's the winning strategy from an economics perspective. My name is Aaron Hartwig from Cambridge Econometrics. I'm a senior economist in the environment team, and with Stan van Hummelen, the director of the project we delivered for the South African PCC, we did some scenario analysis assessing what is the best strategy for South Africa in a changing or not changing world. First, very little introduction of Cambridge Econometrics. So Cambridge Econometrics is an economic consultancy, an international economic consultancy. We have offices in Cambridge, and the headquarters is there, also in Brussels and Budapest. And since 2021, we also have an office in the USA in Northampton. And we work across the whole world. We have we've worked with many international well-known organizations like the European Commission, IRENA, but also gained some experience in South Africa as well. Hence, they work with the Presidential Climate Commission, where we produced the results I will present to you today. And also, we recently worked with the South African Department of Forestry, Fishing, Forestry and Environment. In this analysis, we applied our most well-known model, macroeconometric model, global one, which is called E3ME. It is called an E3 model because it incorporates both the economy, the energy, and emissions perspective of the modeling. And it is a global model, has 71 regions all in all, and South Africa is an individual region in the model. That's why it is a well-suited model to basically assess South Africa's strategy while assuming different scenarios in the rest of the world. It has a detailed sectoral coverage. It has 42 industrial sectors and 27 consumption categories. So it's a very detailed global model, and we use this E3ME model to develop 4 different scenarios for South Africa and the rest of the world. So the aim of the modeling was basically to assess what is the winning strategy of South Africa. Should it decarbonize or not? And we built 4 scenarios where we assume that South Africa and the rest of the world as well goes business as usual, which means that everything goes as the trends dictate. So basically, there is no big push for decarbonization, nor in South Africa or in the rest of the world. And the rest of the scenarios we explored, but what happens if, for example, South Africa goes to net zero while the rest of the world does not decarbonize? In this scenario, we assume that South Africa gets just transition funds to fund the decarbonization investments, while in the third scenario, South Africa does not decarbonize, so it goes business as usual, while the rest of the world goes to 1.5 degrees, meaning that there is a strong push for decarbonization in the rest of the world, while South Africa decides not to decarbonize. And this also means that there are asset taxes paid on, for example, products exported by South Africa with high embedded carbon content. And in the final scenario, we have full decarbonization. So both South Africa and the rest of the world decarbonizes, which means that South Africa gets the Just Transition Fund to fund its decarbonization, and also the world implements policies to reach the 1.5-degree warm-up. Here are the specifics of the scenarios, but without further ado, I will move toward the results. So what we see in the scenarios that basically whenever South Africa decides to decarbonize, so in the scenarios where it starts with an NZ, net zero, the economic impacts are positive compared to the baseline scenario, which is the business as usual scenario. So the way we interpret our scenarios is we always compare the results to a so-called baseline scenario, which is the business as usual scenario. So this number means that if South Africa decides to decarbonize while the rest of the world stays in the business as usual, based on our calculations, the South African GDP will be 8.6% higher compared to not decarbonizing in South Africa, which already signals how beneficial it is for South Africa to decarbonize. However, if the world decides to decarbonize, so the rest of the world goes to 1.5 degree, but South Africa does not decarbonize, so it stays business as usual, we see lower GDP in 2030 than in the business as usual scenario. And also we mapped the different scenarios to the emission targets of South Africa, where we see that if nobody decarbonizes, the emissions relatively stay high in the modeling. However, even if only the world decarbonizes and South Africa does not implement any further climate policies, emissions reductions is a high emission reduction is achieved, since the technological spillovers, meaning that basically when the world decarbonizes, it helps to decarbonize South Africa without any further policies. However, still, if the South Africa goes for net zero, emissions are much lower compared to the other scenarios. So based on the main results, we can already see that decarbonization is always a winning strategy for South Africa, but let's have a more detailed look at the results. So this is what happens with GDP across the scenarios. All the charts are compared again to the business as usual scenario. So what we see that if South Africa decides to stick to the business as usual while the rest of the world goes to 1.5, there is a loss of GDP, which is mostly driven by a loss of exports. Basically, what happens is that since the rest of the world decreases its fossil demand for coal, the coal export of South Africa decreases. That's why South African economy starts to shrink compared to business as usual scenario. However, if South Africa decides to decarbonize, that also means that the domestic demand for coal decreases, and therefore when the globe goes to business as usual, South Africa can export more coal. And in the total decarbonization scenario, although the exports decrease because basically no one will demand coal, the additional investment that the decarbonization requires, and also what the Just Transition funds basically supply, has a very serious positive impact on the economy, and this is the green area here. So this is the investment that is required by the decarbonization. And yes, this is basically what the underlying dynamics of the model. So in the business as usual 1.5 scenario, so again, when South Africa does not decarbonize, but the rest of the world does, there is a loss of export because the rest of the world does not need coal anymore, and that reduces South African export. While in the net zero 1.5 scenario, there are two dynamics. So there is a loss of export, However, the benefits of the investment to fund the transition outweigh the negative impacts of the loss of export, while in the net zero business as usual scenario, so South Africa decarbonizes while the rest of the world does not, the exports grow, and also there is a positive investment shock from the transition. However, if we adjust the results and add the avoided climate damages to the GDP results, we can see that the benefits of the world going to 1.5 is even higher. So you can see that we added the so-called avoided climate damages to the scenarios where the rest of the world goes to 1.5, which means that the avoided damages, so avoiding the climate damages and thus having higher GDP than in a warm-up scenario, is totally reliant on the rest of the world. And this means that basically whenever the rest of the world decides to decarbonize, South Africa benefits a lot from that. And even it makes all the scenarios where any kind of decarbonization happening more beneficial when everybody just goes business as usual. And then taking a look at the energy results. So of course, the emission reductions are mostly driven by the change in the fuel mix and how South Africa consumes energy. And from the primary energy demand, we can see that in the business as usual scenario, basically not much is happening. So coal remains the dominant fuel type in the energy mix, as happens in the business as usual 1.5 scenario. However, when South Africa aims for net zero, there is a sharp decrease in coal consumption, and regardless of the global context. However, we can see that in the net zero 1.5 scenario, there is a greater decrease also in the total energy consumed, the total amount of energy consumed, and the share of coal, which is again, this is the so-called spillover effect that South Africa benefits from the investments, the decarbonization investments happening elsewhere in the world. And although there are substantial amount of fossil fuels still consumed in net zero scenarios, I must highlight that the modeling was around for 2040 and not until the full decarbonization happens. And of course, an essential sector of the decarbonization is the power sector. So a huge amount of the changes in the energy consumption comes from the power generation mix. Again, what we can see here that in the business as usual scenarios, when South Africa does not decarbonize, coal is a very substantial part of the generation mix, even in 2040. However, in the net zero scenarios, basically solar becomes the dominant generation type, and again, which is shows how electrification helps decarbonization. We can see that total electricity demand, so the total amount supplied by the power generation sector, is considerably higher in the net zero scenarios. So this is because electrification happens in elsewhere in the economy, and that's why total electricity demand increases. Still, solar manages to supply most of the electricity, or the total demand is higher. And then taking a look at the sectoral results, because although we have seen that GDP results are positive in the net zero scenario, of course, there are losers and winners in the transition. As we would expect, the losing sectors of the transition is mostly related to extraction, so coal extraction, for example, mining. And we can see that whenever the world goes to 1.5 degree scenario, so the world decarbonizes, because of the loss of export, loss of coal export, the sectoral output in the extraction sector decreases substantially. These are the orange boxes or orangish red boxes here. However, these negative impacts are outweighed by the increase in the industry and services sector. And employment effects basically follow the same trend. We can see that there is a decrease in the extraction sector. However, the gain in employment in the services sector is even more higher in employment compared to the sectoral output, because services sector is a very labor-intense sector, meaning that if the sectoral output increases in the services sector by 1%, basically that's higher employment benefits than if the output increases in the industry sector by 1%. And here are some more detailed results. Again, what we can see that when the world decarbonizes, the extraction sector of South Africa decreases substantially. However, the negative impacts are outweighed by the benefits of the other sectors, and similar impacts can be seen in the employment of South Africa. However, again, what I would like to highlight is the positive impact of the net zero transition in the energy sector, which stems from the higher labor intensity of the renewable capacities. So basically, what we've seen earlier, that solar becomes the dominant generation type in the net zero scenarios. And since the labor intensity of solar generation is higher than, for example, coals, that's why we can see a positive employment impact in the energy sector. Then just a few concluding remarks. So the main message of our analysis and the main result that for South Africa, decarbonization is the winning strategy, regardless of what happens in the rest of the world. So even if the world decarbonizes or decide not to decarbonize, South African economy can benefit from the transition because of the investments decarbonization brings. And what is key to achieve these benefits are the just transition investments, and the just transition funds basically funding the investments required by the decarbonization. And what is essential is labor mobility to realize these benefits, because our modeling assumes that labor mobility is high in the economy, meaning that the jobs lost in the extraction sector can be replaced in jobs opened in the industry sector, meaning that we can reskill the workers and we can move them from one sector to another. And what we also seen from our modeling, that climate damages can have a severe impact on the South African economy. That's why net zero scenario and decarbonization is again the winning strategy, because simply the avoided damages caused by climate change are very substantial in the country. And this is the end of my presentation. Happy to answer any questions. Thank you.
Thank you so much, Mr. Hartwig. That was great. I think it further, shows us that South Africa finds itself quite in a vulnerable position due to the climate crisis, and we cannot afford business as usual. And by not affording it, we don't mean financially, but mainly because there are also socio-economic risks. And we have Dr. Gordon and Mr. Haji Lazaro here today to help talk to us more about that link, that nature-related risk and how it links to socioeconomic risks. It's important that we understand that. Over to you.
Thank you very much. My name is Antoine Godin. I will be the one talking, but Paul is in the room and happy to take any question. And first, let me start with the fact that it's a real honor to be in this distinguished audience. And you will see that I will talk mostly about nature-related risks, but it is important to understand that climate and biodiversity risk are have the same dynamics, and they are tightly interconnected. So even though I will talk about biodiversity, you will see that, and you have to keep in mind that climate is the main driver for biodiversity loss, as was already presented by Francois earlier on today. So bear in mind that the two are interconnected. The study I will be presenting is the outcome of a long-term research with SANBI, the DFFE, SARB, WWF, Conservation SA, and NT. So I'm presenting, but this is really a collaborative effort that has been going on over the last few years. So let me start. What is important to us is that if we want to move forward, we really have to strengthen the policy dialogue around transitions in general. And I think this has been coming clear in the presentation of the first two presentations. We need to have this dialogue emerging between ecologists, economists, and social scientists. Ecologists in general terms, I mean also climatologists and so on, right? So the idea is we have to have this common language emerging between these different science. And to do this, I think the most striking way is to actually just highlight the tensions, the opportunities that emerge between the three different spheres, and make sure that we represent them correctly in what we call a strong sustainability approach, where it is impossible to substitute natural capital with social or economic capital. It is important that if we destroy the environment, it is impossible to restore it by replacing it with social or economic capital. So it's really important to have this kind of common language emerging between these, because it's only by understanding how the connections is being made that we can actually act upon making sure that we protect the environment in general in the right way. So what I'll be doing here is I'll be using the framework that has been proposed by the NGFS, that's the Network of Central Banks for Greening the Financial System, or the TNFD, which is the Task Force on Nature Financial Disclosure, to highlight the approach, to highlight how we can actually build this common language and assess the different risks that we are facing connected to nature. And the two framework are basically constructed around the same approach. One, we have to identify the sources of physical and transition risks. And that's called the locate, the interface with nature in the LEAP approach. Then we assess the economic risk, and this is where we can do the evaluate and assess for the LEAP approach. And then finally, we try to see the effect onto the financial system. I will not talk too much about that. I will really concentrate on phase 1 and phase 2, but we can talk about it if you want afterwards, about the financial consequences that will emerge. How do we do this? Well, it's like basically a construction of data sets that are interconnected. So we will have a lot of different data sets based on nature assessment, based on the evolution of climate, based on the evolution of the ecosystemic services that are provided by nature. And these are based on this biophysical assessment. And in the case of South Africa, which was really great, we had a localized approach where we can go at the municipal level to understand how the ecosystems and the ecosystemic services are evolving through time. And then we have the economic activity. So this is basically an input-output matrix, or again, in the case of South Africa, we have municipal level value added by sector, which is quite interesting because we can then make a connection between the ecosystems and the economic activities and how they depend on them or how they exert pressure on them. And then finally, we connect these economic activity data set with what we call satellite account, which will contain information regarding the socio-economy. So employment, wages, consumption levels, foreign currency, financial asset, fiscal revenues. And it's by connecting these different data sets that we can reveal the interconnection between nature and the economy and then its socio-economic impacts. Right, so let me just explain the first phase, and I will concentrate on water in this case because it's very striking right now in South Africa, but it's also the case in Latin America. I was in Mexico 2 weeks ago, and the situation is very drastic and dramatic also in Mexico. It's the same in Colombia and so on. So you will see, I will use water as an example, but bear in mind that actually we can do this analysis for all of the ecosystem services that are in this graph. So what you see here is all of the ecosystem services that are provided by nature, and here the sectors in the South African economy and how much they are dependent on these ecosystem services. So on the left-hand side here in the green, you have all of the agricultural sectors, and of course they are very much dependent. The darker, the redder the cell, the more each sector is dependent on these ecosystem services. And you see agriculture is very much dependent. And then we have mining sectors, which have a bit of dependency to water mainly. We have then some of the industry sectors that are basically also very much dependent on water, but not so much on the others. And then you have here tertiary sectors, okay? So these are the direct dependency. Now, if you take into account the fact that there are supply chains, and so some sectors are indirectly dependent because they actually are dependent on other sectors that are producing goods and services for them. This is the picture what we have. So you see that now all of the sectors become very strongly dependent on most of the ecosystem services. You can see the difference between the two. So while the dependency on these ecosystemic services are really concentrated on the agricultural sector and to some extent on the tertiary, when we come in direct dependencies, they emerge everywhere. That's at the national level. Now, what we did in South Africa, which was very interesting, is to go down at the municipal level by combining information that says, okay, is there a risk of water shortage in municipalities? And is there in these municipalities economic dependency on water provisioning? That means, is there economic activities that are actually dependent on the provisioning of water? And it's the combination of the two. It's the fact that you are dependent on water and in a water shortage, a high water shortage municipality, that you have vulnerability emerging there. So you can see that we can go further by just saying, oh, you are exposed to these risks. Now we can say you are vulnerable to these risks because you have both activities and risk of water shortage. That gives us the phase one, which is, are we exposed to water shortage? Now, what are the consequences in terms of socioeconomy? If you look at the entire economy and for all of the ecosystemic services, what we see is that half of the economic production in South Africa is dependent on at least two different ecosystem services. That these represent 70% of the consumption goods consumed by households, and it's 80% of the net exports in South Africa. So if these ecosystem services were to collapse, this is the kind of impact that we would have. Exposure, sorry. And then if you take into account the indirect effect containing either the supply chain upward or backward, so that taking into effect the fact that you need goods to produce your own goods and services, and then if you don't produce your own goods and services, then you will constrain other goods and services in the supply chain. When we look at the direct and indirect effect, and this is in the case of water scarcity, you see that we move from a relative low direct exposure to very high levels, more than 50% across the different types of socioeconomic indicators. So the consequences would be not only on production, but also in terms of employment, in terms of net taxes, in terms of bank loans, in terms of household consumption, as I explained, so in terms of export. So it's really fundamental to understand that it's the entire supply chain which will be disrupted. Now, I was mentioning the fact that we can look at exposure. We can also look at vulnerabilities. And here we see that we move from 38% of production which is exposed to water shortage to 10%. Now, you might say, well, it's less problematic. Well, except that these 10% vulnerable water shortage is actually quite large. First of all, 10% of GDP or production is actually quite a strong impact, even more so when you go into export, 22%. But also in these cases, we know that they are vulnerable. That means it's very likely that in the case of water shortage, as was explained by Francois, where he was explaining that Gauteng being on net zero day is a very high risk right now, this has strong consequences in terms of the different service that the economy is providing to the South African economy in general, production, exports, taxes, and so on and so forth. But then what we wanted to do is go one step further and to try to understand what are the socioeconomic characteristics of those that are exposed to these risks. And this is where we look at the type of employment that are impacted by water risks. And again, we concentrate on agriculture and then on electricity, because these are the two main activities that are really exposed to water shortage. And what we see is that we have a vast diversity of types of employment, both in terms of income. So here you have income, and you can see that agriculture is mostly low-wage employment. while electricity actually has a lot of different types of wage structure, but also in terms of skills. And so again, we see that most of the employment in the South Africa in the agricultural sector in South Africa is mostly low skill, but in the terms of the electricity, it's actually much more diversified. So you can see that it's really across the entire spectrum of jobs that are impacted in terms of income or in terms of skills. We went one step further by also trying to understand how much the ecosystem services were providing for the basic needs of population. So this is based on the household survey, where we try to understand how much people are relying on nature to provide for basic needs like cooking, heating, drinking, and so on and so forth. And again, we cluster these dependencies to ecosystem services to have an idea of municipalities that are very dependent on ecosystemic services for their basic needs provisioning. And based on this clustering algorithm, then we can try to look, okay, these municipalities, they are highly dependent. What is the consequences in terms of water risk filter? Is there risk that the water will be short in the coming future? And we can see that those municipalities that have the highest dependency to ecosystem services are also the ones that have the highest multidimensional vulnerability and inequality, and that they are mostly located in region where there's a risk of water shortage. So you see that the vulnerable people from a socioeconomic point of view are also the most vulnerable from nature, in respect to nature. And we showed here in the case of water, but as I said, we can do the same analysis for all of the different types of ecosystemic services in terms of climate regulation, in terms of pollination, and so on and so forth. And we talked a lot about a dependency in terms of ecosystemic services, but it's the same in terms of pressure exerted to ecosystems. So for example, in our study, we can show that mining is in certain municipalities exerting a great deal of pressure on specific ecosystems. And so if you want to reduce this pressure, you're going to have to change the way in which you produce goods and services. And these are, for example, the type of pressure that exerted in South Africa through the different types of activities. So what have we learned from this study? Well, first, we need to foster more transdisciplinary collaboration, and this has happened with SANBI and TSARB and so on. We need to start creating this common language, and in this context, I think the webinar of today is really interesting because it allows to have this discussion between economists, financial experts, but also climatologists, ecologists, and so on and so forth. And we need to understand this idea of double materiality. So both, one, we are dependent on regulated climate, we are dependent on biodiversity and nature services, but also we are exerting pressure on them. So we did physical risk, but we can do the same with transition risk. And then I haven't presented here, but I'm happy to discuss afterwards. We also started to do this kind of analysis on portfolio. So trying to understand how banks, development banks or private banks or public banks are affected to this kind of nature-related risk. We can do country analysis, we can do scenario construction, and we can do more interconnection with biophysical data. So this is really a first step, but more can be done, but we don't have to wait because you can see that we can do it already quite nicely with the existing work. So I'm happy to take any questions right now, and I will stop now and let the floor for more Q&A. Thank you again for your attention.
Thank you, Mr. Gordon. That was incredible. It's so exciting that we get to use different ways of methodologies to understand our issues. I think because we have so many questions, I'm going to open the floor now, and I'm going to take 3 questions from the chat, and then if there are any further questions of people who want to be online, please do pick up your hand and we'll attend to you. But Professor Engelberg, may I start with you? There's a question here or from Lufuno, who says, is there something that we can do to reverse the impact of climate change? The climate has indeed become warmer. Sometimes it's very uncomfortable. And I think you touched a bit on that, Prof, around us being at 1.5 degrees Celsius pre-industrial levels, and how we can't move from that. But there's still hope not to reach 2 degrees Celsius.
Yeah, thank you very much, Jay. I was actually just busy typing an answer for Lefuna. I've typed answers to a few other questions, but it's nice to answer in person. I would say the hard reality right now is that there's no technology we have that we can apply at scale to remove carbon dioxide and other greenhouse gases such as methane from the atmosphere. So as things are standing right now, once these gases are in the atmosphere, they are there for in the order of centuries or longer. So we can say climate change is indeed irreversible in the context of the lifetimes of many generations of humans. And the best way to demonstrate that irreversibility is probably in terms of sea level rise. I mean, one reason why the small island states so strongly advocated that global warming should be restricted to below 1.5 degrees Celsius is that the tipping point at which the Greenland ice sheet will start to melt in an irreversible way is probably somewhere between 1.5 and 2 degrees Celsius of global warming. So then that ice sheet dynamics kicks in. There's no technology humans have that can stop it when the sheet starts melting. And that means, in that type of scenario means sea level rise in the order of a meter this century that will replace hundreds of millions of people this century from where they live. And then we are looking at about 6 meters of sea level rise over the next 2,000 years, which feels far away for us, but it means our generation is the one that will be stealing land, of course, from the future generation, stealing living space from future generations. So that is also one reason why the Paris Agreement was designed to keep global warming to below 2 degrees Celsius, preferably below 1.5. To prevent something new from climate change from happening, something new that we are seeing now, climate change becomes irreversible. So that's another part of this reality. And in our world, it means the climate regime shifts. And now suddenly we have to face with droughts that last so long that Cape Town will regularly face this day zero type drought. And it may start to happen in Gauteng as well, given the droughts in the eastern Megadam region. So Lefune, the short answer is no. Right now, we cannot reverse it. There's no technology that can remove what we are pumping into the atmosphere. And climate change is therefore, at least in the context of the lifetimes of several generations of humans, irreversible.
Thank you there, Prof. And Mr. Hartwig, there's a question here. There are 5 questions here from Loandle, but I'll try and ask the 2. So they ask, can you outline sectors considered for decarbonization in the study? And did decarbonization include energy efficiency in your model? Please, can you just respond to those 2 questions?
Of course. Yep. So all the 42 sectors included in the model are included in decarbonization as well. And as I think I'll quickly reply to that, but just to give some more insights about the scenario assumptions. So yes, we included energy efficiency. Basically, we included energy efficiency in the residential sector and the industrial sector. And let me grab the question because, yeah, I just were about to answer that. So there was a question about trade as well. So on trade, there was one assumption in the business as usual 1.5 scenario when we assumed an export penalty on high carbon goods. So there was a penalty on exporting carbon intensive products, and basically how decarbonization was achieved in the net zero scenarios is also with carbon tax in South Africa, and then based on the carbon tax, the model calculated how the different sectors react to the carbon tax, and that's how decarbonization was achieved. So it was across all the sectors and based on carbon tax, and the model calculated where reduction happens.
Thank you there. And Mr. Gordon, Relin is asking, please share your thoughts on South Africa's pricing natural capital assets and ecosystem services to stimulate investments in nature. Is this possible in the short to medium term future?
Thank you. It's a very interesting question. And so my thought is that, first of all, it's important to recognize that it is very difficult to price nature in general because it's extremely diversified in terms of the services it provides, but also in terms of the way these services are being used by the economy in general, the society in general. So the work that we have been doing was really to highlight the fact that it's not only about GDP, if you want, that is dependent on these ecosystem services. It's actually a vast diversification of different types of services that are given. So it's about exports, it's about inflation, it's about taxes, it's about basic needs provisioning. So putting a price on that would be relatively complex. The second thing is that if the goal is to restore or protect nature, I don't think putting a price would be sufficient. I think it's more of a political agenda and showing that by investing in nature, we actually are able to restore all of these services. We are able to protect the economy in general. So the pricing story is one element, but I think there are other ways in which we can ensure that we restore and protect nature. The second thing is, which is important, is that how to say, the study was highlighting risks, but we actually wanted to show that these are opportunities by highlighting where do we need to act first in terms of water provisioning, but also for all of the other ecosystemic services that are provided by nature, we can highlight where it is important to first act. So if you are thinking about the government, or if you are thinking about a development bank, or if you are thinking about a private bank, where do I need to first allocate the resources I have? The map we drew allows you to understand where is it that in which type of services that you can actually try to act upon. So I don't want my presentation to be only about risk. It's also about opportunities, because we can filter and we can highlight where it is that you'll have the highest leverage. Either directly or indirectly, thinking about the supply chain. So I think rather than talking about can we put a price on nature, I think it's really important to say where should we act, in what kind of service, in what kind of sectors, and let's make sure that we leverage as much as possible those investments to protect nature and protect the socio-economy that depends on it directly.
Thank you, Mr. Gordon. I'm going to move to a question online. Gabi Mkatwa, you have your hand up. You can unmute, show your face if you want, and ask your question.
I'm covered now. I was trying to lower my hand and I just froze on the screen. Apologies.
Oh, you're covered.
I'm covered. Thanks, ma'am.
Okay, thanks, Gabi. Erin, can we ask a question from one of our colleagues, Steve Nichols? He's asking whether you modeled new sectors and sector expansion in South Africa to 1.5 scenarios. For example, investment in copper or vanadium and rare earth minerals. What is the opportunity for further upside in these transition pathways?
Thank you. This is an excellent question. However, as you can imagine, a global macroeconomic model, we do not have the details in extraction sector to model this. However, this is a very fair point that there are other minerals, critical minerals, that can support the transition, and these alternative ways to basically outweigh the losses due to the decarbonization. But E3ME is a econometric-based model, which means that many of the parameters are estimated based on historic data, and new sectors. We have a few technology diffusion models, but not for the extraction module. We use FTT models in transport, power generation, heating and steel, but unfortunately not for extraction.
Thanks, Mr. Hartwig. I'm going to ask a question from Anila, and this could be to Prof. Engelberg and Mr. Gordon, is what message do you have for ordinary citizens overwhelmed by some of the facts presented in the different models, and more importantly, by the prospects of an above 1.5 degrees Celsius South Africa or world? In fact, I'm going to throw this to you, Prof. Engelberg.
I often get this. I'm often being asked this question, and I've never been able to find a good answer, unfortunately. But I'll make one attempt. I'll firstly say it is a reality that some types of changes cannot be pursued by the public on its own. Some changes can only happen if they are policy driven by government, for example. Like South Africa cannot get an electric transport industry if it's not government policy, I would say. So that means there is, of course, all of us can, of course, campaign through the democratic processes towards achieving the society we'd like to live in. So that's one answer.
Yeah.
Another hard reality, before I try to say something positive, is that South Africa on its own also cannot prevent these high levels of global warming from being reached. And, there are really important elections coming up, and we've heard it this morning from Desika, and that November election is really important, he mentioned. And in the end, if the two superpowers in the world are not collaborating to mitigate climate change, we will exceed the 2 degrees Celsius threshold in the 2040s. So in a way, we are vulnerable in that way to impact. So that's also a hard reality. At the same time, all the world's small economies, in terms of emissions, it's very interesting. If you add up the emissions from all the world economies, all the country economies responsible for 1.5% or less of the world's emissions, like us, just over 1%, you get 30% of the world's emissions. So it's really interesting that all the smaller emitters are making up one China. So everybody must contribute to the mitigation process. But it is a reality. This is not in the first place in the hands of the developing countries of the world. That's also a hard reality. But finally, I would say, in terms of adaptation, there is so much that we all can do. And in terms, of course, reducing our own carbon footprint. And I think about the latter, we often speak a lot, but in terms of adaptation, I think there's a lot of work that we can do in our municipalities and in our households, for example, in terms of saving water and storing water. And these big losses of water that happen between the Vaal Dam and Johannesburg, these need to be completely eliminated. So once again, in municipalities, there are many things we can do. There are so many wonderful examples in South Africa of communities starting their own vegetable gardens, for example, eliminating the need to drive and buy vegetables somewhere else, reducing their own carbon footprints. Should we all drive every day in the biggest car we can get between Johannesburg and Pretoria, for example? I don't think so. Yeah. So there's much we can do to reduce our own carbon footprints, to make our households more resilient in terms of outlasting a drought that lasts for months. Yeah. So many positive things we can do, and I guess it depends a bit on every household. Your income enable you to do certain things, and then of course a lot of work you can do in your municipality and in your community.
Thanks, Prof. That's a great answer. Thank you for that. Mr. Gordon, you want to jump in here?
Yes, I would not dare to give any advice to South African citizens, because I know where I'm talking to, but I can relate to that. So let me know, let you know that in France the same questions are appearing, even though the situation might not be as drastic as what Francois was presenting before. We are nonetheless in a situation where droughts are happening in regions where you did not have droughts in the past, that agriculture is suffering and so on. So I think it is important to know that we are all in the same boat and collectively we are failing. So it's not a question about saying, oh, let's point the finger at someone. Of course, responsibilities are different, and I'm not disputing this, but I want to say that I think this overwhelming feeling is felt right now globally. Especially, it's of course it's very much present in the tropical area where you have very high temperature, we have lots of humidity and so on. But it's something that is also happening in France right now. So this the fact that we are dependent on public policies, as was Francois explaining, but also that we have collective responses that we can give at the community level is very important. And so in that aspect, I think we are not different. And I just wanted to highlight this and not put only the burden onto your shoulders. It's also coming from the global north.
Thanks for that. Can I just keep you? We have an anonymous attendee who's asking this question. The future predictions on water scarcity are very concerning. What is government's plan on addressing this issue? I'm not sure if you know, but it'd be good to hear your thoughts. Will the carbon tax funds go towards climate resilient infrastructure? And how can private financing be leveraged? I mean, just your thoughts, Anton, and yeah.
Yeah, it's difficult for me to give you a clear answer on what the South African government will do or won't do. I unfortunately am not in that circle. Though what I can tell you is that with SANBI and DFFE, based on the study we have been doing, there has been more stakeholder engagement with the different municipalities and the Water Commission to try to respond to the highlight that we gave in from a scientific perspective. And this is the goal for me as a scientist and working for a public development bank, is to really say, okay, my goal is to highlight where we can feel there will be tensions, where we can feel there is leverage point and opportunities that emerge, and then feed as much as possible to the public policy makers and ensure that they take the most adequate response given the fact that we have given them. And this is part of I was mentioning at the very beginning, the fact that we take this strong sustainability approach where we cannot substitute nature with others. One of the elements of the strong sustainability approach is to recognize that the decision-making is a social construct. It's not something that you can impose from science, because if the future that we are designing is not desirable, then it will not happen. So this is where we really have to have this engagement. And I think this is extremely lively in South Africa. And that's coming from where I'm coming from. I have to admit that the quality of the debate is very interesting. Hopefully it will lead to actions in terms of public policy dialogue and in terms of actions. But at least that discussion, the fact that we are building this common language, that we are ensuring that there is a commonality and common understanding of these issues is crucial. So yeah, it's difficult for me to have a very clear response in terms of what the government can do. I can give you some examples of what is being done in France and also failures in that aspect, where, for example, they were using, there's a lot of debate right now on the fact that we are trying to build water storage that is taking water from underneath, and that we can use that for irrigation systems. And there's a lot of tensions around that, because while you are taking the water which is underground and putting it into the surface, which means that they can go it can warmer, or you can have evapotranspiration, and so that you might be losing water. But on the other hand, the agricultural sector is saying we need that water because our crops will die. So you can see that all of these policies need to have a systemic approach and try to understand with ecologists and with economists, try to make sure that they are adequate for the response they're trying to give. So yeah, I'll stop there because it's difficult to give a very clear answer, but hopefully it gives you some insights.
Yes, it does. That was very helpful. Thank you. Prof. Engelbach, did you want to come in?
Yeah, I want to add that one really important thing we can do at a community level is the establishment of so-called flood-based, community-based flood early warning systems. So when the Durban floods happened in South Africa, April 2022, 544 people lost their lives, by the way, on the 11th and 12th April. That is our worst flood disaster in history. I can just mention for the sake of the international colleagues here. But there was one community known as the Quarry Road community, where the community leaders and the University of KwaZulu-Natal have been talking to each other about flood risk for many years. And the university hydrologists contacted that community the day when the flooding started. And there was a big evacuation that saved hundreds of lives that night of the 11th of April. So I think this needs to be scaled up. So I think yeah, national disaster management, provincial, and the big metropolitans in terms of disaster management have a big role to play here in terms of improving how we respond in South Africa to mega flooding. Because in Eastern South Africa, KwaZulu-Natal and Eastern Cape, that type of flood risk is also increasing. So we need to become much better in evacuating people in South Africa than we are. So that's also a response to the previous question, but also just as a contribution to this question about drought. You know, we started last year to run a really big project. We are running several hydrological models forced by climate models, and we are trying to generate now a probabilistic estimate of the risk that this day zero drought will occur in the next 10 years, in the next 20 years, and so on. And when we were writing this proposal, we went to the Department of Water and Sanitation and the National Disaster Management Center and a few other key institutes, and everybody gave us letters of endorsements for this project. So I go back to what I said earlier on. I'm very positive that many government institutes in South Africa are really serious about, they understand that there are climate change risks. They want to understand it better. But what is missing, I think, right now, for such a drought that is unprecedented, remember, there's no example of this in the historical record. I don't think the disaster management plans of the city of Johannesburg, Tshwane, for example, take into account the possibility of such a drought. And immediately we must learn about Cape Town. You know, Cape Town struggled when they were challenged by such a drought initially. And one of the big issues, for example, is who must get the water. There was a long debate about the water allocations. And such things must be sorted out completely. When we are going into the third or fourth year of drought, it must already be agreed to whom will the water be allocated, who will be facing which types of cuts when. So that we are all managing this drought as well as we can, so that we start with, for example, strong water restrictions timelessly enough to give us a chance to outlast the drought until the next La Nina event comes. So I think just a basic management plan for 3 to 5 year droughts, to the best of my knowledge, remains outstanding in the big cities. And I would say I think that is also the case at the national level. And that is a very basic thing we can get in place as an adaptation measure.
Thank you, Prof. That was excellent. Can I ask Mr. Hartwig a question by Richard Worthington? And he asks, does the model look at socio-economic indicators other than GDP, perhaps disaggregated across the population? And why is there so very much more solar than wind in the electricity supply projections? Is it entirely a product of cost assumptions?
Yeah, thank you. So again, the model is a global macroeconometric model. So unfortunately, we are not able to produce distributional impact, for example. We have very nice macroeconomic indicators like employment, output, GDP, and so on. However, recently we developed a simpler economic model, social accounting matrix based model that was also developed at provincial level for Mpumalanga and Eastern Cape. And there, using micro-level data, we managed to produce distributional impacts. So I think that is a very interesting bit. And also, we produced some results. We fed basically the results of E3ME into that simple model to have some distributional impact. So that is going to be an open source model. You can correct me if I'm wrong, but I really recommend to use that tool for this type of analysis. And regarding the solar generation, yes, the generation mix in the power sector is estimated by the model so-called FTT power. This is a diffusion model where the different technologies compete with each other, and the base of the competition is the levelized cost of generation. So what happens is basically a lot of countries across the globe installs solar PVs, and this drives the cost of solar PVs down, and this results in a high share of PV. So this is totally model driven, and we use this so-called FTT future technology transition model to estimate that.
Thank you so much, Mr. Hartwig. Commissioner Naudé, you're up next. But before you go on, I see you answered an important question here by Vali, who says,
there's a naughty piece in there, so maybe don't read it.
No, I'm just going to ask you to respond to it online, however you wish. So how can we build private and public partnership contributions to build resilience, given the scientific evidence that we have so far?
Oh, okay. That's quite a difficult question for me to answer. I do think, what maybe needs to sink in with all of us on this call is that the world we live in now is a world of climate changes. And, therefore, everything has to be done to minimize these climate changes to where we can still live on the planet, us and other species, as humans. And everything has to be done in a climate smart way. So, if you're a planner in a municipality and you're thinking of building roads, you've got to think climate. Every single thing we do has to be done being climate resilient and low carbon. And so I think that is going to take public-private partnerships, because there are some things that is not the job of the state to do. It is the job of the private sector. So yes, I do think there is a role for public-private partnerships. I just always have a bit of a caution that sometimes public-private partnerships have the state carries the financial risk and the private sector benefits from the financial profit, if there is any. So, let us not design our private-public partnerships like that. But what I did want to talk about is that one sentence in one of the presentations. Firstly, I must congratulate everybody for outstanding work. And, my first reaction with Professor Engelbrecht, you just want to lie down and weep, like really. But anyway, one has to pick yourself up and, carry on making efforts, which is what the Commission tries to do. But in one of the presentations, there was that sentence about you can't substitute economic, social, and ecosystem services or biodiversity and natural systems dynamics for each other. And I think maybe the importance of that sentence really needs to come to the fore. So I'm going to try and say it in my own words. It means something like this to me, and then the presenter will correct me if I've got it wrong. Human well-being has a value in and of itself. We want to maximize human well-being. We want our citizens to live fulfilled, lives not on the poverty line. And that is something that you cannot maybe reduce to a GDP number. Or, yeah, some kind of financial number. We just have to have a set of values, in fact, that says we as a society value that as an outcome, that people are flourishing. And of course, everybody's definition of flourishing and what they want to see for themselves and their community and their family is different. But, is that a value we put in our hearts? And then I must say, this was a webinar about the intersection of biodiversity, economy, and climate. And while there's been outstanding work on the dependency on ecosystem services, it's quite easy for all of us to think about water and think, yes, we are dependent on that in very many ways in different industries and so on. But, biodiversity is something that it's not just water. So, we are dependent on soil and water for our food. And soil is a little ecosystem itself. It's got hochos living down there. And we have to say we actually value the resilience that biodiversity brings to the system. So, stop paving over the soil with concrete because you're killing all the soil organisms and we need them. So in a sense, biodiversity, we have to understand why we value it. And again, it's not necessarily reducible to a number on a spreadsheet or a balance sheet. But, otherwise we're going to end up people with cockroaches and rats. And actually we'll be lucky if we have cockroaches because there's an insect apocalypse going on. Thank you, Commissioner. Bye.
Thank you, Commissioner. Can I please ask Steve to come on?
Yes. Good afternoon, everyone. There've been a couple of questions about distributional and justice impacts within these kinds of studies. And I just want to remind everybody about the PCC's overall program on modeling and communities around modeling. And so although you can't necessarily address some of those kinds of questions with the macroeconomic models that we've been talking about here, we have been commissioning separate pieces of work looking at some of those distributional impacts. So while they're not yet ready for publication, that's kind of the next phase. So the key message for me coming out of these studies is that once you start considering biodiversity, climate change, socioeconomic risk as a counterpoint to economic pathways, so externalities is a word that we like to use. You start to see that economic strategies that align with 1.5 degree pathways are most suited to South Africa. But we still have to think very carefully about the distribution of the returns of those economic pathways. So apart from it being a second phase of study, it is also something we have to think about in how we design these economic pathways and how we think about policy. And as you know, this is kind of the core focus of the PCC as a whole. So just letting people know that work is underway and we hope to have some more concrete results towards the end of this year. Thank you.
Thank you, Steve. So I think we should draw to an end. We do have 10 minutes, and I'd like to give our panelists an opportunity just to reflect on the webinar today, maybe respond to Commissioner Naudé, and in a minute, please, can you give one last passing shot? Could I ask Professor Engelberg to take us off?
Thank you so much, Jane. And yeah, thank you also to the Commissioner for a really powerful intervention and many positive thoughts shared. Colleagues, what I'll share today is that I think we need to realize that the 1.5 degrees Celsius world is dawning. And the climate science is very clear that it is a more dangerous world. and that we can already detect increases in extreme weather events, as mentioned by Jessica at the opening of today's event. We can in fact already detect these in every inhabited region of the world. So my message today is that we need to, across all sectors, embrace the climate science that give us an indication of what to expect. In terms of climate change adaptation, it is of critical importance that the unprecedented events that we will have to deal with over the next 2 decades are not also unexpected, because when they're also unexpected, they are the most disastrous. I think our country has been doing so well. We've been having these dialogues going on for many years. We are one of the countries in the world where the government speaks to the climate scientists. That's extremely positive. We need to continue to do that as we find our way through the just transition that we all want.
Thank you, Prof. Appreciate it. Mr. Hadvik.
Thank you. So first, again, I would like to thank for organizing this excellent event. It was really exciting for me as well to listen to other research and other analysis. And yeah, as I kept repeating during my presentation, I think it's essential to realize that decarbonization can have positive economic impacts. So although for years economists were saying that it is in equilibrium and it leads to economic losses, but we believe that the additional investments stemming from the decarbonization can have positive impact. However, we have to keep in mind that it requires special attention to the sectors where losses happen, so the other sectors can thrive. Thank you.
Thank you, Mr. Hadvik. Mr. Gordon.
Yes, I also want to thank you for this very interesting discussion, and the quality was high, and the quality of the questions were very high. So I think it speaks volumes of the understanding of what we have been trying to present. To me, well, I'll take 2 outcomes, well, 3 actually. The first one is indeed biodiversity cannot be simplified to only water, and there has many different aspects of biodiversity, both in terms of dependency and in terms of pressure that are exerted by society in general onto nature, and we have to keep it into context in connection with climate. And so to me, these are the 2 faces of the same coin. The second one is that given we have so much uncertainty and so much complexity at hand, we have to have guiding principle to help us choosing where we want to go. And this is where we were pushing for this idea of strong sustainability, which assumes that you cannot substitute between economic, ecological, and social capital. You cannot replace one with the other, which implies that you have to have this multidisciplinary approach to transitions in general, but also, and I think this is a very good point that was raised by Commissioner Node, that implies that you have to have this social construct where we discuss the value of what we want, and this webinar is clearly contributing to this construction of a common language. Where do we want to go? What are the different paths that allow us to get there? And the third point I wanted to make is that we don't need to wait for more elaborate modeling to come. We actually have already answers. We have already strong evidence. The question now is, where do we act? Where do we prioritize? And how do we make sure that we get to where we want to go? And I think this is really critical. We should stop wasting time to have a more elaborate answer on these complex matters. We can act now.
Fantastic. Thank you, Dr. Gordon. And thank you so much to our panelists, all 3 of you, for such rich and insightful presentations that I think will take us far. You know, we would like to thank, for example, you know, this research, which is, oh, Steve, you want to come in quickly before I close?
No, sorry, I was trying to find the applaud button. Apologies.
No worries. But yes, a round of applause to the 3 panelists. You know, this research has been commissioned by a range of government departments, from Treasury to SANBI to the Department of Forestry and Fisheries and Environment, as well as the PCC. And this is a live debate within government with the South African Reserve Bank, who are also thinking about this. And what's clear is that, we cannot ignore the costs of physical climate risk, biodiversity loss, and trade when we are thinking about economic strategy, especially considering the impact on the poor and vulnerable. When we consider these questions in selecting economic strategy, we see that pursuing a 1.5 degrees Celsius pathway is beneficial, regardless of what the rest of the world does. So we will continue to explore these questions with more local models and researchers. And it's important to keep these collaborative efforts in understanding the multifaceted challenges of climate change for achieving a substantial future. And it's important that we continue to engage with each other on a regular basis. And, this is the work of the PCC. So we look forward to seeing you next time. And thank you for coming.